Hey guys, Mrs. Traver here. We're going to do our notes on 4-5 properties of logarithms condensing this time. So we've already done our notes on expanding. So I rewrote the properties up top. They should be familiar to you at this point. So let's jump in. We're going to do probably, 5 or 6 examples of these. All right, so let's jump in. So number one, we are given log base 5 of 8 minus log base 5 of 12. So the product property, because there's subtraction, this is going to be a quotient property here. So we can rewrite this as log base 5 of 8 over 12. And then let's just simplify what's inside the parentheses there. 8/12 has a common factor, and we can make this be 2/3. So log base 5 of 2/3. All right, that one was pretty nice. Number two, let's do 3 natural log x plus 5 natural log y. So right off the bat, I see some coefficients. I see an adding happening. The 3 out front and the 5 out front, those I can put back as exponents. And then the adding will make it be a multiply. So it's going to be x cubed y to the 5th. So natural log of x cubed y to the 5th. All right, what if we had 3 times the quantity, log base 3 minus log base x? All right, so first off, there's this 3 out front that'll come all the way over here. And then on the inside, we've got, I should probably write my problem with any sense at all. This will make more sense. Let's make these be common logs. There we go. So now they're the same base. If they're not, you can't do any of this business. So on the inside, I've got 3 over x, and then it's all to the 3rd. Log of 3 over x, and then it's all to the 3rd. All right, let's look at some more. Number 4. Say I had log base 4 of 5 plus log base 4 of 8 minus log base 4 of 2. So we've got a multiply and a subtract. So PEMDAS says you go left to right. So let's do these guys first, 5 times 8, and then say over 2. So log base 4 of 5 times 8 over 2. And we can obviously simplify this. 5 times 8 is 40. 40 over 2 is 20. So log base 4 of 20. Let's do another one. Let's do 4 times the quantity, natural log x plus natural log y minus natural log of the quantity, 2x plus 3. All right, so first we've got this 4 way outside, and he's going to come here. And then on the inside, again, I have a plus and then a minus. So I'm going to have x times y over this thing. Let's do that first. So we've got the 4 on the far outside. So natural log of the quantity, x times y over this business. So xy over this business, all to the 4th. All right, that one looks good. Let's do number 6. We'll try one with a square root in it. So 2 log base 2 of x plus 1/2 log base 2 of x minus 1 minus 3 log base 2 of x plus 3. All right, so I think, all right, so we've got, notice, a number out front, number out front, number out front. Those are all going to come into being our exponent. And then I've got an add, so we'll do x times x minus 1 over x plus 3. So the plus, these ones will multiply. So I've got log base 2 of the quantity. So x squared times x minus 1 to the 1/2 over x plus 3 to the third. And if there were any common exponents I could pull out, I would. I think the only thing that can happen here is a canceling on top and bottom. So let's do that. On the bottom, I'm gonna expand this. And I'm going to rewrite this as a square root. On my bottom, let's actually FOIL this into x squared plus 6x plus 9. And we'll call it good there. Let's do one more. The last one on our last problem, our last notes was tricky. Let's do a tricky one here with number 7. Let's say I had 6 log base 3 of x minus 5 log base 3 of y minus 2 log base 3 of z. So notice I have 2 minuses. So I've got, first off, I guess let's move in our exponents. So 6 will come here, 5 will come here, and 2 will come here. And then I've got 2 minuses. So let me write it out the long way first. Let's just do our exponents. And now we want to do something that's going to look really strange, but I'm just going to go for it for a minute. X to the 6th over y to the 5th over z to the 2nd. That looks horrible right now, but here's what we can notice is I can kind of extend this fraction bar for a minute and think of it as this fraction divided by this fraction with a 1 under it. And remember, when we divide fractions, we do like keep, change, flip. So I'm going to write this as keep, change it to multiply, flip it. So now instead of z squared over 1, it's 1 over z squared. And then now I can multiply these fractions. So I'm just going to basically shove it all together to say x to the 6th over y to the 5th z squared. All right. Another thing you could have done, if I don't want to belabor this problem, but notice that there is a minus on both of these terms. So if you wanted to, you could have said minus this thing and then added them instead. So essentially factoring out that negative, then you would have had x to the 6th over y to the 5th z to the 2nd, which maybe would have been quicker depending on which way you look at it. We'll stop there. Hope you guys, that helped you guys out. I will see you next time.